as to how to think about innovation in a way probably attached to more of a conventional university view of innovation. So that's really the two objectives today. So let's get started. After this class, we really want to have you understand the innovation process, and online you can see that we have defined innovation, but I want to have you understand that really what we're after here is a way of thinking. Is at the end of this class, we want to have you be able to think about, okay, here's how the real innovation process works, and you have a view of how that's really invariant with time. We see a lot of macroeconomic things going on. We see bubbles. We have all these other factors, but the human process of innovating never changes. And you'll see in the online lectures that we have examples from 500 years ago, from 100, 150 years ago, and from just 10 to 20 years ago. And so hopefully through what we're showing you in this class and teaching you the innovation process, you'll be able to see and understand how innovation works all the time, and then you can interpret what's going on in the macro system and learn how to move your ideas forward. The innovation process is extended over a long period of time, and so we really want to have you experience a beginning of that process, because obviously the class is only so long, but we want to get you to experience that first beginning of that process, and especially deal with the uncertainty that's required in the innovation elements, which I believe you've already seen online, but are market, implementation, and technology. So getting you to be experienced with that and being able to actually, when you think about an idea, fill that space out yourself is very important. Another aspect is the quality of the research you do behind this. I'll mention later that the internet is a huge advantage today in early innovation process. In fact, in most of my innovations, I started them because some of them are fundamental and they took 20 years. At the beginning, we really didn't have this kind of great tool that you have access to. And however, as much as a great tool that is, quality matters, and how do you weight different pieces of information. So hopefully you'll with experience, learn how to use the internet and perform quality research. Really important is this last one, which is discovering your relationship with the innovation process. And that's really important because people have different goals. Not all of you in this class have the same goal. Some of you are thinking that you're core innovators. Some of you want to manage innovation. Some of you might want to create a situation in your ecosystem to have the highest rate of innovation. And what's important is, as you go through this process, it's always good to understand how innovation works, because at a minimum, we're all going to be involved in this one way or another, because innovation is a source of growth. Except for demographic growth, which involves, increasing numbers of people, the rest of growth comes from innovation, and so which increases productivity. And so, in one way or another, everyone will be, related to this process one way or another, and you determining how you picture yourself fitting in. Do you like to be a core innovator? Do you like this process, want to be the one kind of driving it forward, or do you want to set the stage so that others can innovate and you work in a team with core innovators, for example? Or do you want to invest in innovation? Do you want to understand this process so you can understand the uncertainty and where things are in this process, and is it optimal for an investment? So I think understanding your relationship with the innovation process is one of our learning objectives in this class. So very simple learning objectives are very, very important. This is not a class that says, oh, it's all about raising a ton of money in the shortest period of time and trying to get a financial transaction. Those are more closely related to the world of finance, Here we're trying to build real innovative value that can create waves of change for 10, 20 years, depending on the scale of the innovation. And that is the real value that builds jobs and growth over time, and also your own personal innovation and company if you decide to go that way, or helps the company that you are being employed by. So I want to cover this again because it's really important, and in your online videos we define innovation, but for today's lecture there's kind of two pieces I'd like to go over. One is what is defined and undefined in a problem set, and the reason I define this way, I know some of you are not engineers or scientists by training, but I think you know what happens in the universities in general is that as we learn, we have a specific kind of technical problem that we go out and work on. And I want to take that experience and kind of expand from that and say, look, this is how we're trained as scientists, engineers, or as economists or whoever. But I want to then say, look, innovation is much bigger than that. It's only one tiny piece. Whatever you learn in the university is only one tiny piece of actually the whole innovation process. But I want to start from that little tiny grain because we've all been to universities, we've all been trained in a particular way, and I want to add the other pieces of how innovation happens just from a collection of knowledge that you acquire at the university. And then kind of setting that up, I just want to today then say, all right, fine, what is innovation then, and how do we proceed forward? And that's connected, of course, to what you're learning now and what's going to be online. So let's start with the first thing. So typically, in science and engineering education, we learn through problem sets. So we kind of set up and say, for example, here's a cannon, and I'm going to launch a projectile. And one of the great things about physics, for example, is that if you know the velocity here and a bunch of other variables, and we can predict exactly where this projectile lands. Now, if you think about this problem, and of course the university is composed of all different problems like this. We, solve D, or solve for the velocity at the top, or there's all sorts of different ways in which we are taught technical specialty. And so there tends to be a focus, of course, this is definitely in our element of technology. But what I want you to focus on today is to think about when we set up this and teach you how to do these types of problems, what is variable and what is fixed, okay? And of course, what we find out is an awful lot is fixed. This causes an inherent problem that what we've seen, especially in the U.S. with engineering and science students, is that when they go out, we say, great, you've understood this little piece of technology, now we want you to go have innovative impact. And we assume that just because we could teach you how to think through some novelty in a very fixed world, and you've got a new idea in technology, that somehow that's going to translate into innovation. And I want to use the problem set to show you that actually it's really quite a distance and too little information to know whether that idea is really going to be a valid innovation in the marketplace. So I want to further develop this concept by looking at what is fixed and variable in such a problem set. So I think you can see the way I've kind of set this up. The problem sets are the purposes of education. That's the reason we do this. They're actually not innovative in themselves. They're problem solving within a very tightly constrained environment. However, I don't want to minimize this. When I speak like this, oftentimes scientists, engineers will get upset with me, and they'll say, you don't think this is valuable. I said, of course, we need to know the important details of how things work. Otherwise, we can't come up with new ideas, right? So it's very important. It's just not sufficient. And these ideal situations that we typically set up in the university, in the classroom, but even sometimes in PhD thesis or projects or whatever, they're really ideal situations. They don't prepare us for the full innovation process, which what we want to do in this class. Okay, so let's look at such a thing, and let's think about what's fixed in the context of the innovation elements that you're being introduced to inside our class. So let's look at the application of this example that I gave, right? So first of all, it's very, very specific, a projectile landing in an exact spot. So that's our application. I've set it up that way. I could calculate that. Hold on a sec. Hey, you guys, can you do that? I'm hearing a lot of interference. So it's a very specific market application, and we're saying that we want to have this projectile land in an exact spot. Okay, so it's a very specific market application already. You can see that. We've also assumed that it's important in an application like war, since the problem set says so. We have to assume that having a cannon and being launching something is an important problem that needs to be solved. So we're also assuming that there's a general war application there, that such things are important. Again, we didn't have to determine that. That's already fixed. Let's look at implementation, which is the way in which we bring technology to the market application. Someone has given us a cannon, a field, the location, and the gunpowder, right? So we don't even have to think about any of that when we solve this detailed problem set. And you know, there's an awful lot of elements that are components that are given to us where we have no uncertainty, right? Everything is fixed and precise. The other thing is, of course, it is assumed that, you know, in this process that I'm being paid or fed or both, meaning that I don't have to worry about all the people that are required to go launch this cannon. And so a separate unknown organization is funding all of this activity in this problem set. So that means that capital, resources, intellectual property, they're all fixed. So technology, even in technology, things are kind of fixed in this problem set. The velocity that the projectile is at coming out of the cannon is known. The launcher, they're all given. But we ignore a lot of details, like wind, other people, what are other organizations doing? And ultimately, this is a one-body problem. That is, that we don't really need to think about who else is doing this or how that affects what we're doing, right? And we explain this, of course, as a way to focus on one concept or one piece of technology when many could be operating in reality. So we typically will, you know, do this and purposely make it very simple idea. Notice that this is also true for projects in university or even a PhD thesis, where the advisor will set up all these boundary conditions. And so what we do in the PhD, we have to think twice about whether, you know, just having an interesting result or having a particular technology is really something that can go out into the marketplace and create an innovation, right? So I know that this is a drawn out, very simple example, but remember that one of our learning goals was the way of thinking, right? So I wanted to go through this in this specific way to show that oftentimes when we think about technology-led innovation, we actually focus quite a bit mentally, just like we do in the problem set. We actually fix so many variables, and we believe that this particular piece of technology as is super important. And what innovation thinking is all about is realizing that no one can predict the future, and that all of these things, if I really want to impact the world in the future, need to have variability attached to them. I need to purposely introduce uncertainty, and it's completely opposite thinking of thinking that I've been able to calculate something or produce something that's this little piece of technology and it's really, really important, right? Important in our definition is having an idea in the marketplace, and it gets back to our definition of innovation. So let's flip this around now and thinking about, I want to have this idea go into the marketplace in the future, and I do have some technology knowledge. So let's think about, in that world where I'm thinking more like an innovator, let's think what's variable. Parameters that are only in the exact phenomena are being taught, and the importance is completely unknown. But importance of thinking of this is inferred by the educational institutions. So in other words, if you think about it, as I try to go out in an innovation world, I actually don't have a weighting of which area of technology is more valuable than another. So for example, here at MIT, if we tell students that they're going to get a degree in material science and engineering, we may tell them that they have to solve all these problem sets in thermodynamics, and really it's up to the student to believe that the institution is giving them value and telling them that these are important things to know for innovation in the future, right? So there's an inherent belief in the education institution that I'm collecting all of this technical knowledge and somehow it allows me to solve real world problems in the future. Of course, nobody can predict the future, so they have to be, by definition, common across many aspects of market application. So again, you can already see now, as you start to say, what am I being taught and what is really the most important thing, you start to see what engineering departments in science tries to do. They try to teach you common problems that actually are useful when you think about many aspects of different applications, right? So already you could see that even though the problem is very specific, the institutions are trying to say, well, these things in general may show up in many different innovation processes in the future, and at least you'll be able to think about this. And this gets back to the importance of understanding technical detail. That is very important, but you know, there is a weighting that intrinsically is going on inside this process, and we're trying to use common things that allow you to do many different innovation processes where that piece of knowledge may be useful. Okay, so let's go up. We're already saying, okay, what knowledge do I need to know and how can I think about the future? How do I know if this idea or set of knowledge is going to be used in the future? And remember our definition that's in this class, that innovation is the embodiment of a useful idea in the marketplace. And I want to emphasize this last part. So innovation's a buzzword, and people use it in many different ways. In fact, if you look at online definition, it's changing with time because the modern connotation is different from what it was 20 years ago. So 20 years ago, this word just meant ideas. Innovation is just an idea, right? If you look today at the online definition, it's something like an idea through a process or product or something like that, right? In our case, what we're saying is that we have to be all talking about the same thing. So we are going to define innovation as the embodiment of a useful idea in the marketplace, okay? And that's because if you look at governments and you look at companies and you look at individuals, the modern connotation is that that it's not just an idea, but it's been through the whole process and it is having some impact in the marketplace. This also avoids the problem of financial transaction, which is that typically people will confuse sort of, I make a startup and then I sell it very quickly and I've made money on that transaction, and you know, depending on all the bubbles happening in the United States, it's quite possible But of course, we don't define that as innovation because there may not be a product at the end of the day in the marketplace, right? If you look at a lot of mergers and acquisitions, 80 to 90% of them end up resulting in no difference in the marketplace. So essentially, M&A is a very ineffective way to get innovation, which means that a lot of what you're seeing today, there's like a huge M&A thing going on, really isn't going to, statistics show it won't matter much. So the marketplace, an idea in the marketplace, operating and doing something useful is really, really important. And of course, from a government point of view, that's important because that creates jobs, growth, and wealth. So in fact, even though bubbles are great for creating financial transactions and flipping companies, just like here when we had a bubble in real estate, we can flip houses. They don't have any lasting impact in the marketplace. So that's our definition. We want to connect that to, okay, we might have some technical ideas, but how do we bring them to the marketplace?
Gene, can I ask you a question?
Yes.
Is commercialization an essential part of innovation? So where do you draw that line? You say some impact. How you define this? Do you know what I mean?
Yes. So the way we have this definition is that commercialization is part of innovation, because if I have a useful idea in the marketplace, by definition, when people use the word commercialization, they mean that it's been commercialized, right? That it is functioning inside the marketplace. So again, that's a very important part of how we're defining innovation. So an innovation is not really an innovation unless it's sitting out there, right? If I am in my lab and I've done this many times, I have lots of patents on things that work, but they actually, for many reasons, did not get to the marketplace. Those are inventions, but they're not innovation.
I asked that question on purpose because even around MIT, some people say it's innovation, though there was no commercialization of the product. So some people say patent is still an innovation. That's why I asked that. So
exactly, and that's one of the reasons why in this class we're trying to create a common language, and at least if we're going to teach a process and pedagogy inside an academic class, you have to make a definition and follow that definition. And like I said, this is based on the connotation that's actually used by universities, entrepreneurs today, and government and corporations, which is that they're interested in impact of ideas in the marketplace actually leading to jobs growth and wealth. Okay? So again, I think I'm beating a dead horse here, but my ability to do a problem set is therefore not innovation, and I just pointed out that my ability to make working inventions in my lab are inventions, but they're not innovations either. So as we get further with our class here, and I think you started to do this in this first week of class, inventions and knowledge and my ability to have certain problems solved in a technical space, these are all components of technology. They give me options, but by themselves, they're not innovations the way we define it, okay? So that's an important, another corollary on top of how we're defining this. Let me erase this so that you can see this better. So I'm going to deviate here just a little bit because, as Yelena just pointed out, at MIT even, we're just making this transition now. This is all the leading edge stuff we're talking about here. And the question is, why was there a tendency to think this way? And I think it's useful for a little digression here just to think about this a little bit, because generally, when you want to advance thinking or innovate, if you will, kind of assuming that everyone was not very smart in the past is never a useful way to think about things, because in fact people are very smart. So it's a better question is to say, how have we been able to live all this time, thinking this way? And really it's because of the way we've been structured. For example, the United States of America, after World War II, we had large vertical companies that immediately afterwards became pseudo-monopolies because there wasn't much industrial infrastructure worldwide. And so it was the case that we educate students like this. They would go off to a company, huge vertical companies, and there was some other entity, in this case a corporation, that was responsible for what we would call innovation process today. So in other words, I can learn all my technical information inside MIT, and I go off and work for MIT, for AT&T or HP or one of those large corporations, and it would be assumed that there would be an organization that would be working on bringing ideas to the marketplace. So I didn't have that responsibility in those days, right? However, such a case requires unusual circumstances in reality. Remember I said post-World War II, right, where many, many American companies had market dominance. So you get an era of perceived stability where you assume that there's some sort of large enterprise that is essentially taking my technical knowledge and they're responsible for bringing it to market. There's also another way this can be done, and I'll talk about both of these in a second, which is that there could be a society-wide innovation paradigm, for example, the information age, that actually is kind of self-organizing many companies, right? And therefore, I could work on one little piece of technology and I could transition that to all these companies because everybody knows what's needed in the future, right? So let me talk about each one of these cases in a personal situation for me. So when I graduated from university, I went to AT&T, which in the United States at that time was the mother of all large enterprises. It was the most widely held stock in the United States, and it was initially a monopoly. It owned the entire telecommunication system in the United States. So that allowed it to develop things like AT&T Bell Laboratories, which is where I worked, where it was a great place for initial fundamental innovation, which we'll talk about in the lectures that you're going to see. I could tell you for a fact that everyone assumed that there was a machine, some sort of thing inside AT&T that would take our ability to do all these specific technology problems and commercialize them, right? And of course, one of the great transitions of our time is seeing that these large enterprises eventually became so large that they're not very good at doing that. And I learned that personally because I was at the end of this wave, and you'll see that story coming ahead in the lectures. So I was entering AT&T right at the transition, but I can tell you I saw the old world when I went in, and it was the perceived stability in this gigantic enterprise that someone else was responsible for taking my really great ideas to the marketplace. Okay? Now, different people respond different ways. In my case, I became frustrated that I started learning this was not the case, right? That actually we were way beyond those days, and that all of these great ideas were not moving forward in any organized way. So of course I left and decided to come to MIT and then start a few companies on my own, to understand more about that. Now I want to talk about the second part of this, which is this innovation paradigm. And an example that is Moore's law, which many of you may know, which is doubling of transistor density roughly every 18 to 24 months, which occurred for 40 years. Okay. So once such a law, which is really an innovation paradigm, like I was saying up here, becomes clear, multiple companies don't need to get together and constantly talk about where's the future. There's this massive economic growth demanding higher transistor densities, which make better integrated circuits, which make better computers and internet switches, which allows the internet to form, and all of this gets built on top of this platform. And then amazingly about this platform is that we increase the transistor density again, and then every 2 years the entire bottom of this food chain gets rebuilt, throwing off growth and wealth like crazy for 40 years, right? So that's also a way in which it makes life easier for us. So we could say, what things are needed specifically, what pieces of technology are needed for increasing transistor density? We know it has value because the paradigm is already telling us it has value. So a lot of this uncertainty goes away and we get closer to the problem set again. We feel comfortable because, oh, I know what to do, because if I use this material to shrink these transistors, this paradigm has told us over all this time that that's valuable. And so there's a tendency for other people, without even doing the process of innovation, to value those things in that way. So these are kind of very, very specific circumstances in which we get closer to this sort of problem set. And of course, that's why engineering schools in the US post-War II tend to be aligned this way, is because that's what was happening post-War II. Large corporations absorbing people, saying, you just work on that little technical problem, and then we'll worry about what happens after that. Outside of these unusual situations, and again, historically, they're very, very unusual. Paradigms are unusual, like Moore's Law, and sort of times when there's large numbers of vertical enterprises dominating the market are also unusual. And of course, the market eventually wants to disrupt both these things and remove them. So what this means is, outside of this typical situation, and like I said, even though our engineering and science schools in the U.S. are kind of geared towards these still to this day, they're starting to transform. It's why we're teaching innovation at MIT in a different way. And really what this tells us is that it falls on us, meaning you who are taking this class, and me, and the organizations that we are in and interact with, to understand the innovation process. This is probably the largest transformation worldwide that's occurring in education, especially in thinking about the connection between technology and the marketplace in my lifetime, and probably it'll be the largest shift occurring over like 100 years. So we cannot think the same way. We can't only think that technology, which again, remember the way we're setting this up for you in this class, that a little piece of technology they know is only a component in this larger set of technology, and I've got to worry about different kinds of applications and different kinds of implementation, and how can I move forward with this uncertainty and actually have a chance of finding a viable innovation path so I know where to go. And that is what this class is about. So if we now ignore what I just said and try to go forward thinking the old world, I would get very nervous, like I was just saying, because the market application is a variable. If we go back to my specific example of the cannon launching the projectile, let's suppose that's my little piece. I just love that world, and that's what I do. Does anyone really want to make this happen? I mean, in this other environment, people told me to study that, but the question is, does anybody really want to make that happen out there in the world? Is it mostly nation-state enterprise? So, governments, are they really the only customer, or actually is there a commercial customer? Is there somebody that, really wants it? And how much does each market application, how much are they willing to pay me to create such a thing, right? So if I start looking beyond a particular first application that I was told says they want this by some other organization, maybe a university, the question is, how much is each market application willing to pay? And that's really important, because as you'll see, that's a price, right, which you put into the market part. That's how much people are willing to pay to have that kind of thing appear in market application. Are there other applications where the kinetics of projectiles are important? What I mean by this is, well, I know about, if you think about the cannon, it's really not just launching this thing to land in a certain place. What I really know are the kinetics of projectiles. So are there other markets where that's important, right? Does it have to be the way I'm thinking in this war market or whatever? It could be useful in a lot of other markets. So this first slide says, of course, you can see immediately how in reality market application is a variable. Implementation is a variable because the minute I start thinking like an innovator, how much does it cost to make a cannon or acquire it and operate it? This is something I didn't have to worry about before. How much capital should I expend? You know, I could build a really beautiful cannon that does really important things, but I don't really know if those are needed, right? So, you know, but if they were needed and I knew I could get a high enough price, that would be important, right? Who owns the intellectual property for various pieces of doing all this? You know, who owns the intellectual property for the bullet or the cannon or the gunpowder? And what are the implications then of what I do? So if somebody owns all that, should I just quit? Or should I take all that knowledge and go to a different marketplace? And even though I'm using some of their technology, maybe the price in some new area that's been unexplored is high enough that I can pay royalties. Who already makes the pieces that I need? For example, the first thing when people start to realize that, oh, it's really more complicated than just my technical idea, I start to realize, oh, I'm going to go build all this stuff, right? And then, well, what you really should be thinking is, well, who else knows how to build pieces of that? What price do they sell it at? Maybe I don't have to worry about that. Maybe I can focus on only where the new technology is and I can kind of purchase all these other pieces, but when I put the whole thing together, that thing doesn't exist and I can make a large impact in price in that particular market application. Can I afford, you know, so even though I'm doing all this, you know, can I really afford to buy all those pieces? Because if the market doesn't want that at a high enough price, well then I have no margin and I can't afford them, right? So implementation is clearly a variable. And then finally, something we thought was fixed, but you know, I was kind of implying this by saying technology is only one component, right? So in fact, technology is still a variable because, well, there could be other technologies besides a cannon that are good at shooting projectiles. For example, a railgun, right? Are those better? When are they better? What about the different applications I'm looking at? How accurate do we need to be? Something that we never asked in that problem set was, well, these different technologies, do they have different kinds of accuracy, and what's the value of accuracy in these different market applications? The projectile should be made of what type of material? We didn't really talk about that. We just assumed that it was made from something, right? What other technologies are required to make the innovation work for a particular application? So even if I have great knowledge on the material to be used in the projectile and the gunpowder, well, it turns out that the way the cannon's made and all that stuff may be really important if I push the edge of technology on gunpowder and projectiles. So even though one piece of technology may not be a variable, in the innovation process, there's all these other components that are going to be important. So I'm kind of giving now a brief overview of I've sort of set you up saying, wow, you know, as I go forward and I try to think about a real idea and move it to the marketplace, market implementation and technology, how do I deal with the fact that there's so many things to worry about? You know, I'm overwhelmed because it's kind of a scary proposition. Well, the good news is that they all affect each other. And so new science and technology components are added to technology in order to figure out how many market applications we can do. The price that's available market determines the range of cost and implementation. And these are just examples of how they interact. And if I buy all my components or I make them all, it depends on what other companies are doing that determines the cost. So even though it looks like you're developing all these ideas in market or implementation technology, they're related, and the fact that they're related allows you to throw things out. So as you move forward, you can try things. You could say, well, I want to build this prototype, and in building that prototype, you have a much better idea about costs. And then when you figure out those costs, now when you talk to people in particular market application space, you start to realize, hey, some of those market application space can work because they'll support that price, others won't. So as you see when you go forward with your own idea, we're going to teach you how to have market implementation and technology interact with each other in order to reduce that uncertainty, right? There are other aspects of innovation that also help you out and are necessary. One is that at first you say, wow, I want to consider a lot of things. I want to think about all these applications and all this technology because I have a higher chance then of converging on something to make a viable innovation. Well, if you do that, there's a counter argument, which is that there's more cost because it takes time and resources to figure out how to explore all of them, right? So that's a decision that has to be made. How far into the future am I going to look, and how many resources do I have? Do I have to be more incremental? Do I have to look only a year or two out and not consider so many things? The important thing here is that no one can predict the future, that the last thing you want to do is pick very specific market, a very specific implementation, a very specific technology, and do a rifle shot, because that's gambling, right? What we're going to teach you in this class is an innovation process that increases your chance of finding a viable innovation in the marketplace. And the important part of that is iteration. Since you can't predict the future, you need to do little steps, get feedback, so you can find the right path that you'll be on. So iteration is going to be an important aspect of what we're teaching in this class. Of course, that requires time and resources as well. So if I have more things I consider, it's going to take more iteration, takes longer, and I better have the ability to develop that over a longer period of time. So minimizing all these resources requires working on the riskiest piece of market implication technology first, and we'll talk about that as you go forward in this class. One of the problems we always see with innovators is that they work only on their favorite parts and not on the riskiest part, right? If you're going to be efficient at de-risking things, you have to be working on the sort of area that has the highest uncertainty and de-risking that because it affects the other elements in the innovation process. So a few comments to close here before I take some questions. We're really lucky to have the internet. You'd be surprised how you can de-risk so many things today on the internet. In the early days of my entrepreneurship, we didn't have that, and we used to get on a plane really to go around and figure out, you know, what is the market application really going to be. I have to talk to zillions of people. You still have to do that later on in the innovation process today, but you can do the front end of it so much easier. So this is a great time for innovation as long as you can start to understand a pedagogical way to execute on innovation. And so this really accelerates early stages. A little caution, I mentioned this at the very beginning, that the internet's fantastic for that, but you want to think about quality of sources as you move forward, especially when you work on your own project in this class. There's sort of rule of law backing a few qualified sources. So when you want to find out about companies, for example, which have useful information about various things, SEC filings in the U.S. are useful to look at those, for example, because SEC filings are controlled by law, and so the information in them has to be accurate. Same thing with the patent database. In Europe and the U.S., around the world now, everybody's gotten onto the same kind of rules, and so that's a very good database. And of course, libraries also are backed by various pieces of rule law, especially your local domestic library. So those are a few sources, but there are market forces that back a few things. For example, journal databases, right, which are controlled largely by large publishing companies. Those are very good, right? Of course, if you're academic, you're very familiar with that, and those are pretty good. However, there's very useful sources. They are very useful, but they have no oversight, and I think you're familiar with Google and Wiki, etc. So they're useful, but part of this process is that you have to learn to understand how to place weight on sort of these random pieces of information on the internet and kind of extend connections so that you can figure out and triangulate in order to find out what the value of those sources are. So that's the introduction to the class that I wanted to do. Hopefully I didn't scare you off. As much as we have to introduce uncertainty to innovate, we are going to teach you a process on how to manage that, and we'll even have some, you'll see how you can interact with software in order to help you de-risk that. So maybe I'll stop there, and I think Yelena, for questions, you want them to write in the chat window, and then you can kind of pick some out for me?
Yeah, I mean, we are open to questions right now. There is actually a question not related to your lecture directly, Jean, but been asked so many times via email and during this chat is what kind of ideas people should pick. I mean, Andreas went over it. We're talking about ideas that they will work as teams.
Oh,
Yeah,
for the class.
yeah.
For this
But
class?
people keep asking what type of ideas. And that's question number one. And the question number two around.
Okay, well, let me do them one at a time, right?
Okay.
All right, so for the class, obviously based on what I just said, the best way to pick a topic is to pick one, of course, that doesn't exist yet in the marketplace, right? So for example, if you were to pick a stylus for a display, right? Well, I mean, here I have one, right? And I've been using it to write on there. So obviously that's not a very good thing because it's exactly certain. Now you could take something like that and then go into uncertain space, right? And say, well, it's going to be a stylus to be used for something else or something different, right? The point is you want to pick something that has enough uncertainty that you have room to work in, right? And now it's really hard in a sense because if you just kind of sit back and think about, well, what everybody's talking about, generally those are kind of very simplistic ideas too, right? So I would pick something that you know, really intrigues you. First of all, you should be interested in it because if you're kind of just doing it because it's the first thing you thought of or whatever, you know. So I would pick something I'm passionate about, pick an area where I'm passionate, and think about, well, what could happen in the future? What do I want to see in the future? What seems to be something that would be very useful? And I wouldn't, besides that, I wouldn't worry about it too much because part of what we do in this class is whatever that idea is, we try to get you to open up each one of these innovation elements, technology, market application, and implementation, so that even though your original idea is sort of there, we try to open up those spaces so that as you move forward, you might change the idea, and that's really how it should be, right? So think about this if you're, you know, sorry to collapse into science and engineering world, but consider this to be t equals 0 state when you know it's going to shift into some other state. So don't overly stress or panic about, you know, it's not the best idea in the world or whatever. Just have some uncertainty to it and project forward, and then the whole process will take over and will help you develop that idea in your team, you know, towards the future.
Well, the second question, I think you partly answered it already, but people are concerned about how realizable idea is at the end of the course. For example, I mean, what kind of results should they expect? If they, for example, can only do a prototype, but is it something they have to be able to execute themselves completely throughout the course?
Sure. Yeah, so any academic exercise, and this is a course, right? So it's an academic exercise, is in itself fixing variables. So just like I talked today about how the problem set fixes something, right? Even though we're trying to open up and explain things and how it works, we're still fixing a lot of things here. It's only, the class is only so long. All of you only have so much time, right? And these are things actually that the innovation process needs to be free and variable, just like everything else, right? So already you have to realize that this is an exercise, that it's a way to learn how to think, right? And that for 99% of you, you're going to take the way that you learn how to think in this class, and you're going to operate on some ideas in your company or at your university or wherever over a much longer period of time and try to find a good innovation path. So the answer is that um, if some of you have been working on things for a long time and you have more information about each one of these universes in technology and market and implementation, it could be that actually you uh, can narrow this down and take it forward afterwards. But I would say that the most important thing here is to learn the thinking on an idea, and it's better to choose one that you're interested in, because if this could lead to you pursuing this innovation process beyond this class, it's fantastic, right? And we would love to hear from you about how that proceeds, right? But again, I just want to caution you that this is a limited time in order to get you to think a certain way, and we would be very excited if things could actually be carried forward after this, and we've helped you, start to do the innovation process for something you really care about. But that's not required.
Do you have any questions about the presentation itself? У кого-то есть вопросы по самой лекции? Я вижу очень много вопросов по идеям, я отвечу на них все, что мы делаем как в среде, но вопросов по самой лекции я не вижу, поэтому если есть вопросы, пожалуйста, задавайте их сейчас. Second. Да, ответ, презентацию мы сделаем запись. Sorry, Jen, I'm just gonna say it quickly in Russian.
I have to leave like 10:05 or something.
We'll let you go in 2 seconds.
Yeah, no, it's okay. I just have to. Yeah, that's fine.
То, что касается, okay, so let me do it in English first, and then, so yes, we'll have a video of this lecture. That's one thing. Second one, guys, all organizational questions, please dismiss right now. Jim has to leave. So if you have questions for Jim specifically, please ask them now. And all organizational questions, idea questions, I'll answer the questions once he's gone. So I saw Alexei Shipov had a question. So can you just type the question here or raise your hand so I could unmute you? Окей. Алексей, я не видела вопроса, напечатайте его еще раз, пожалуйста. I'm waiting for a question, Jen, sorry.
That's okay.
Oh, Jesus. Okay, no, I think they're gonna ask questions after that, so it's okay. I'm muted. You try, Alexei. Try to ask the question right now.
Yeah. Hi, Elena. Hi, Jean. Can you hear me?
Hey. Yes.
Yeah. Hi. My name is Alexei. Yeah. Thanks for the class. Yeah. I mean, I think we have a perfect head start with this class. Really.
Oh, great.
Yeah. Whatever I heard today is really like mind jamming. Okay. So I have a couple questions on the on this material. First is where does our relationship to an innovation belong to? Is that market application or technology or I mean yeah.
Did you mean, so at the beginning I mentioned that one of the objectives of the class was you understanding your relationship with the innovation process. Is that what you're talking about, or are you talking about like,
Yes.
um, okay, so what I meant by that was that this class is meant to get you all to go through the innovation process, to understand how it works, how humans innovate, and that we start with that, and you can interpret in various organizations, society, how that can function or whatever. But different people at the end of the class will have different ideas then about how they want to deal with an innovation, right? So, in other words, some will say, like you heard the question that was just asked, maybe there's some people, they actually really always want to be core innovators. They're interested in going out and now using this process to innovate and to think about how am I going to get something in the marketplace and how do I impact things, right? So,
Right.
I would call them a core innovator, right? But some people might say, this is all really interesting. I'm glad I took the class, but I don't want to be a core innovator, because that's what they figure out from this class. They say, well, for me, I want to be near it, and maybe I want to help people do it. So I want to manage it, and then their role is different, right? They might not be necessarily the core innovator, but maybe they're a company and they're trying to create an innovative environment so that people can innovate in the company, right? In that case, they still need to understand the innovation process, and this class is still useful, but they've decided themselves after taking this class that, hey, I really excited, but I want to try to transform my environment and have all these people that want to be involved in core innovation to do that, right? And other people might be like, even a step further back and say, now that I understand this innovation process, I can have a metric of how far they likely are dealing with uncertainty and how much iteration they've done, how far they are from the marketplace. That gives me information then, if I'm an investor, about maybe how much I want to invest and whether it's too early or too late or whatever, right? So the largest analogy I could draw is probably something like physics, right? So we might have everybody take physics, or a large number of people that come through MIT take physics, but not all become physicists, right?
Right. Yes.
So but we still think that's important, obviously, because in the world of MIT, that's one of those broad things that's probably going to be needed to be known anyway, right? I would argue innovation is like that for the whole population, which means that if you're going to attach yourself to growth in an economy, to be honest, you really should try to have a picture of how it works. That's how important I think this is, right? Of course, it's going to start in innovation. It's going to start in like MIT and like your University of St. Petersburg, places like that. That's where it's going to start. But actually, I really do believe that it's something that, to some level, everyone should understand, because otherwise different parts of society don't understand where growth comes from, right? So
Right. By being an innovator, I should really be looking to change both market, implementation, and technology at the same time, right?
yeah,
So
if you want
if
to be a core innovator, then being able to handle uncertainty in all three of those elements all the time, and to be tracking them and to understand what's going on is important, actually. And I wouldn't make the decision now. The point is to make the decision after the class, because we see this all the time. There's people that think they're not core innovators, but then after they see the whole class, they kind of get it, and they start realizing, hey, maybe I can drive this a little bit more myself, right? So I would, you don't have to make the decision up front, right?
right,
Just like
yes,
when you take physics, if you talk to people with a Nobel Prize, they actually didn't really think they would win the Nobel Prize when they're taking their first physics class, right? So I wouldn't decide now. That's part of the class is to see, hey, at the end, what do I think, right?
The bar is set high,
Yeah,
Nobel
thanks,
Prize.
thanks. And I
Alexei,
have a
Alexei, I'm
second
really
question
sorry.
if you
No,
allow.
unfortunately, Alexei, I'm really sorry about that, but he needs to run. So, I mean, Jin has to run.
Ran out of time?
Yeah, we ran out of time. I
Oh,
mean,
sure. Yeah,
Okay,
sorry.
but
next time we'll try to leave more time for the questions, okay? And for
Sure.
the faculty. And when it comes to organizational questions, I'm gonna answer all of them in Russian right now, and we're just gonna let Jin go.
Okay. All right. Well, thank
Sure.
you very much
Thank
for
you.
listening. I look forward to talking to you guys on the next live lecture online, and then I look forward to seeing you in a month as well. Okay. All right. So see you next time.
Так, значит, то, что касается организационных вопросов. Вы меня слышите все, я надеюсь? Значит, вопросов несколько. Во-первых, можно ли поменять команду, поменять область? Да, вы можете послать нам запрос, вот, и мы постараемся максимально, то есть команда уже, многие команды уже сформированы, но если мы сможем, мы постараемся дать вам возможность поменять команду. Значит, дальше, то, что касается идей. Вы начинаете присылать мне идеи на почту. На самом деле идеи нужно засабмитить в вашем портале. У вас на вторая неделя есть строчка Compliance and Idea. Сегодня вечером можно будет ввести. Просто вы от команды введите одну идею. Каждый индивидуально введите одну идею. Какие у нас еще были вопросы организационные? Если у вас какие-то есть организационные вопросы, которые я еще не ответила, да, Любовь Орлова спрашивает, разве не 3? Да, правильно. Можно ввести до 3 идей. Форму презентации просто несколько параграфов, которые описывают каждую идею. Да, ответ правильный. Значит, должно быть 3 идеи на группу. 3 идеи на группу. Вы внутри своей группы должны договориться, какие идеи вы презентуете. Пожалуйста, то есть мы получаем письма о том, какие идеи лучше. Вы внутри своей группы решите, над которыми вот вы как команда хотите работать. И тогда в среду мы обсудим. Я попросила там подписаться на 20-минутные слоты. По-моему, большинство из вас как команда уже эти слоты заполнили. Я подтверждение пришлю. Слот будем все будет проходить тоже в GoToMeetings. Вам просто нужно будет во время вашего слота подключиться. Так, значит, повторяю еще раз, идеи нужно засабмитить на вашем портале. Просто вы как команда, каждый из вас одни и те же идеи засабмитивает. Вот и все. Значит, в каком формате будет защита идей? Я уже говорила много раз, это будет в формате 20-минутной консультации с Андреасом в среду, в тот тайм-слот, который вы выбрали. Значит, защита идей будет происходить в форме того, что вы эти идеи презентуете, мы вам даем обратную связь, а потом это уже мы вам даем рекомендацию, над чем мы думаем, вам стоит работать, но это ваше конечное решение, над чем вы как команда будете работать, мы не будем вам это навязывать. Я присылала, значит, вопрос о том, где можно выбрать слоты. Я присылала имейл с выбранными слотами. Евгений, я вам отдельно, Меньшиков, я вам отдельно пошлю еще имейл. Значит, посмотреть видео встреч можно будет потом в онлайне. Я думаю, что... Но самая, в принципе, большая польза – это общение с профессором напрямую. То есть мы постараемся в будущем давать меньше времени на саму лекцию, больше на живое общение с профессором. То есть ответ – да, мы вам предоставим видео всех лекций, но я сильно рекомендую их посещать. Вот. Так, я так вижу, что, значит, вопрос о том, когда крайний срок, я не очень поняла, когда крайний срок, Любовь, в каком смысле. Крайний срок подачи идей, до вторника вечера, чтобы мы успели их в среде прочитать. Так, я вижу, что кроме того, что некоторые люди еще не поняли, где можно найти тайм-слот, все остальное... Значит так, господа, значит, еще раз. Значит, еще раз и последний. Значит, презентуем 3 идеи как команда. 20-минутный слот будет с вами как с командой. Если у вас нету, вы еще как команда не выбрали себе время, напишите мне, пожалуйста, отдельное письмо на почту. Значит, просьба во время указывать в формате московского времени достаточно сложно, потому что весь софт у меня работает в том времени, в котором я живу. Это бостонское время. Но я во всех письмах буду указывать и эквивалент московского времени. Вот, значит, то, что касается, как это будет после того, как люди отберут конкретные идеи внутри команды, единственный способ для вас, если вы ни к чему не привязались, будет привязываться по принципу идеи. Да, презентация словесная. Значит, вы хотите это сделать в виде презентации как презентации, пожалуйста. В принципе, достаточно словесной презентации. Значит, в течение 10 минут презентуете идеи, в течение 10 минут идет обратная связь. Я ответила на все ваши вопросы. Значит, вопрос такой, значит, несколько вопросов. Значит так, да, вы увидите идеи других групп после того, как внутри группы они решат, над чем они будут работать. Да, ответ все 3 идеи за 10 минут. И последнее, после того, как будут озвучены идеи, над которыми команды работают, если в команде еще будет место, мы дадим возможность присоединиться. У нас, видите, некоторые команды получились из 5 человек, некоторые команды получились из 10 человек. Ну, в общем, то есть ответ такой, мы сделаем максимально, чтобы вы работали в той команде, которая вам комфортна. Ну, в общем, вопросы уже пошли по кругу, будет ли опубликована транскрипция данной лекции. Ответ – да, она будет опубликована. Значит, в слотах вопрос такой. В слотах записываются как персоны, а не команды. Но они так записываются, потому что вы невнимательно почитали мои инструкции. Я просила вас записываться как команда. Вот, то есть, ну, те, кто записались как люди, я буду смотреть, кто к какой команде прикреплен. Но это, естественно, увеличивает количество работы. Но если вы посмотрите, некоторые команды, которые внимательно прочитали мое письмо с просьбой подписаться, они подписались как команда, а некоторые люди подписались как индивидуалы. Вот. Ну, значит, вообще на самом деле, Павел Глотов, значит, с вашей командой мы уже разобрались, с вами мы разговариваем в 6 часов вечера по Новосибирску. Вот. А все остальные вопросы за другие команды я как-нибудь разрулю. Спасибо. Там, по идее, опции, что разные команды выбирают одно и то же время, не должно быть. Потому что, как я написала в своем письме, кто первые пришли, должны быть в состоянии занять слот. Ну, по крайней мере, я вроде так это делала, такой сетап. Ну, разберемся. Все, у вас вопросов больше нет? Как определять, кто говорит от команды? Ну, господа, вы внутри команды решите, кто из вас будет делать презентацию, кто вам кажется больше это понимает. Это еще раз, это все-таки командное решение ваше, а не наше. Можете так сделать, чтобы один человек презентовал одну идею, другой презентовал другую, как вам комфортней. Так, ну, я надеюсь, что больше, то есть не то, что я надеюсь, но у вас больше вопросов нет. Если есть вопросы, давайте уже заканчивать сейчас. Пишите мне в личку. Ладно, всего хорошего, до свидания. Всем хорошего дня. Спасибо за то, что пришли на лекцию.